Hi, in this video I will talk about some random things like everyone asking, like some of you asking some questions, so I will answer them in this video. So first talk about misunderstanding about the battery backup. One thing is like this is not a real 2500 milliamp battery, so it's a 1 amp battery, 1 or 1.3 amp. So it doesn't the battery backup is 2 hours because of the battery storage is not good. If you use a 3000 milliamp hour battery, 3000 milliamp milliamp hour battery, so you will get backup at least 6 hours at least, because this consumes 600 milliamp around. So without using any extension here, you can get a backup around 6 hours with 3000 milliamp hour battery. So that's the thing. So the another thing was is this module. I got an USB-C one. You will get micro USB or mini USB one, so it's up to you which module you want to use. This module comes with like 3 different types: one with USB-C, another one is mini, and another one is micro USB. And so that's it. Another thing is, if you don't find this Mosfet, so you can do it using the module. There is a post in Hackaday. I will link to it in the like button below. So you can use this chip to switch on and off the mutantC. You don't have to use this Mosfet and the 2 resistor, but it's not recommended because this module is for battery protection. So if you use this module to turn on and off the mutantC, it will be risky because this module is for protection of the battery, so it doesn't overcharge or over discharge. So if in case you don't get this module, this ICE Mosfet, you can use 2 Mosfets here, 2 types of here. This one is 4622, so either this one or like another one, you can use it. So this is the first one, I think. The second will be the 3D parts. You can see there is 4 3D parts. If you look at it, this is the first, second, third, and fourth. So only 4 you want to print out, then you will get a basic mutantC. So that's about the 3D parts. I will talk about the which types of material you should use to print this 3D parts. What ABS, PLA, and SLA. So this one is ABS. I will show you the other 2. And this one is the first one. This is the PLA, and this one is the SLA. Yeah, so this one is the SLA, and this one is the PLA, and this one is the ABS. So the third thing is, I know some of you talk about like this 4-inch display is so expensive. I know, but this is the highest amount of screen size you can fit on it. It's 4-inch, or like you can fit a 4.3 inch also, the biggest amount of screen size. So I think if you want to make one with the lower cost, so you should go with the 3.5 inch. 3.5 inch is like far enough for this handheld PC. So I will suggest the go with the 3.5 inch first. Then if you like the whole thing, then upgrade to a 4.0 or 4.3 inch. This is an IPS also. I don't remember. Maybe this one is from IPS. Also, this is not a real one. It's a Chinese made. It is equivalent to a WaveShare one. And the fourth or fifth, I'm not counting. So that display board, there is enough room. You can use the camera module here with the ribbon cable and attach the camera module here. I'll make some 3D parts for the extension. You can use some STEMA module from the STEMA or Qt module from the Spark Fun. I'm making extension for it right now. So the thing I'm talking about, it's the camera module. So you can connect. There is enough room. There is you can put the camera module, and you can put a hole here. Then you can use the camera module. Also, there will be like the camera module will take this much of space. So there is enough space here. There is enough space to put the extension. It looks like this thing will be, there is no enough storage here, but there it is. Here you can put the PCB here, and there is like enough also the clearance on the top. Also the another thing is like the size. So there is gap also here. I'm thinking about like putting a buzzer or like a vibration motor to get feedback from the keyboard. This also another thing I want to talk about is the size. It's really hand small. Like this is a normal scale. From this part to this part is like 140, and from this part to from this to that, the thickness is like 35 millimeter, and this size is like 80. So, and another thing is the cost to make one. It depends on your country, also like which fabrication you are using. I used some cheap home like local shops to make this one, like all the 3D, make the 3D parts. I don't have a 3D printer, so I asked a shop to make some 3D parts for me. So they made this 1 2 3, and these two from another printer. So without the most costliest part in this build is like the pi, and the first one, the second one will be the screen, and the third one is the all the parts, the module, the circuits, the resistor, etc. So don't worry, you can make one by yourself. It's very cheap. If you got a 3D printer, then it's like more cheaper. I figured out all the cost, like I bear it, because like making this prototype, I made like earlier three or four prototype after the version 1. So this is the fourth one, I guess. After the version 1, this is the fourth one. Other between version 1 to 2 there is 3. So 3 prototype. Those I will show you later when I'm talking about the 3D printing part, 3D printing parts. Then I will talk about it. So don't worry, it is very cheap to make one. Those modules are like $1. Those $2 probably. This battery will cost you maybe $5. And the 3D printing, I guess $10, all the 3D parts, 10 or 15. That will be maximum will be like, if you use a good PLA or like good printing material, then it will cost maybe 10 $20. But if you want to go cheap, maybe 10, from 10 to $20 you will make it, like you'll make this one. It's a very good handheld, or like UMPC micro PC. Also, I want to talk about another thing, is like why I made this mutantC. Because uh, first I saw the Sidekick, then the Sony UMPC, then I saw the other Nokia phones. I wanted those I wanted those to use in my daily life. I also wanted to hack it, but those are really complicated piece of softwares, and also hardware I can't modify it. So I thought, like, don't invest money or time on those things, old devices from 10 or 20 years ago. So don't waste your time or money, then make a newer one with the Raspberry Pi so you can hack it as we wish. It's a very cool device to hack it in software, also in the hardware. So that's why I make it, so everyone can make one, instead of buying a old piece of hardware from 20 years ago or 10 years ago. You should make this one. I will recommend making this one, making a device like this, then modify it as HARTS content, and you can modify the software, modify the hardware as you wish. So that was it. I'll talk like 3D parts in the next video. Also, please subscribe from in my YouTube channel. I will continue uploading these types of video to encourage the whole community to make one. Because if we grow, if we can make one, then this community will grow, then more hacks will be there,